Okay, now we're just going to move on to some slightly harder ones where we're going to simplify. Now looking at part A, we can break 16 up into log 2 to the 4 and then bring the 4 out the front. However, we can't do that to the 10. To simplify this one, what we can do is, because the bases are both the same, we can multiply the 16 times the 10, and so we can say log to base 2 of 160. Now because 160 can't be broken down into an additional format, that is as simple as that one's going to get. Okay, part B, same deal again. So this time, because we've got the same bases, we're going to go log to base 3 of 7 fives of 35. And that's as simple as that one goes. Okay, part C, now if we take 5 and we keep multiplying 5, we recognise that 5 to the 6 equals this value. So log of 5 to the 6. And then that equals, because we can bring the 6 out the front, 6 log 5 of base 5, which equals 6. So we can solve that one without the calculator. Okay, part D. Now again we can break the 8 up as a 2 to the 3 and bring the 3 out the front. But if we do that, we can't use the multiplication rule. And we want to simplify it. So knowing that the bases are the same, we can multiply these two. So we end up with that equals log to base 6 of 16. And the good news is that 16 can actually be shown as log to the base 6 of 2 to the 4. So now we can bring that 4 at the front, and we've got 4 log to base 6 of 2. So that's fully simplified without going the next step and using your calculator. Okay, again, 4 could be broken up into the 2 and 2 brought out the front, but we can't do the same sort of step for 20. So rather than doing that, because it's minus here, then we can do the division rule because the bases are the same. So we end up with log to base 2 of 20 divided by 4, which is 5. And that's as simple as that's going to get without using the calculator to solve. Now this one, both these numbers can be set up for indices of base 2. However, we're going to do the division first. So log to base 3 of 81 divided by 27, which equals log 3 of base 3. And that is simply 1. Right, moving on to part G, we could break this up into an indicial form of 5 squared. However, we can't do it with 100. So we're going to do a division of 100 divided by 25. So we've got that equals log to base 5 of 100 divided by 25, which is 4. Now we can show that that's log to base 5 of 2 squared. Bring the 2 out the front, and that equals log 2 log to base 5 of 2. Part H. Now, because this is plus, we do the multiply rule. Both bases are the same, so we can go ahead and do that. So it's 20 times 1 and 5, or 1 and 5 times 20. And that equals log 2 of 4, which equals log to base 2 of 2 squared. Bring that down the front, and that equals 2 log 2 to base 2, which is simply 2. Okay, part I, we've got the same base, so we can go ahead and use the multiplication rule because the logs are adding. So log to base 4 of 30 times 1 on 6, which is the same as 30 divided by 6, equals log to base 4 of 5. And that's as simple as that one's going to get. Part J, we've got a minus here. We've got the same bases. Let's perform the division rule. So that equals log to base 10 of 4 divided by 16, which equals log to base 10 of 1 on 4, and that equals log to base 10 of 4 to the negative 1. We can continue to simplify it, so we can bring the 1 down the front for the power rule, so it's negative of log 10 to the 4, and that equals negative log to base 10 of 2 squared. Bring the 2 out the front, equals negative 2 log 2 to base 10. Alright, now part K, again, same bases. It's a negative, so it's a divide. So we can use the division rule, so log to base 2 of 4 on 5 divided by 1 on 5, which is the same as saying log to base 2 of 4 on 5 times 5 on 1. You just flip that over and turn the divide into a multiply. And that equals, cancelling, the 5's cancel out to give 1 log to base 2 of 4, which we can further simplify using the power rule and bringing the 2 in the front, equals 2 log 2 to base 2, which is simply 2.